You're standing in front of a panel full of 4 to 20 mil amp wiring that looks like a spaghetti bowl. 16 instruments, 32 wires running everywhere. One's already failing. You're thinking there's gotta be a better way. Well, there is. That's Foundation Fieldbus. And it changes everything about how you wire, think about, and control your field devices. Let's dig in. So, Foundation Fieldbus? Look, at its core, it's pretty elegant. You take one shielded twisted pair cable. One. And that cable carries both power and data. Not some light-duty power, we're talking about feeding your field transmitters, your solenoids, and your instruments without a separate power supply. It's a digital, two-way, multi-drop protocol. IEC 611582 standard. Here's the thing. You already know analog wiring. 4 to 20 milliamps. Right? One pair of wires per instrument. You want to talk to a transmitter, you read the current. You want to control something, you send current. Simple. But man, it gets crowded fast. With Fieldbus, imagine a highway instead of individual dirt roads. You have one highway, multiple vehicles on it at the same time. Everyone's got their own address. Everyone's talking. Power flows down it. Data flows down it. That's the mental picture. One cable, everything connected, everything communicating. The signals use what's called Manchester bus-powered signaling. Don't worry about the technical name too much. Running at 31.25 kilobits per second. That's not fast by modern standards, right? But it's fast enough for field instruments. We're not streaming video down there. We're trading control, data, diagnostics, and configuration. It works. Now here's where people get confused. There's not just one Foundation Fieldbus, there's two flavors, H1 and HSE, and they're completely different beasts. H1, that's the field layer, that's the one I just described, 31.25 kilobits per second. Trunk and spur topology, you got a main trunk line, and devices branch off it like tree branches. You're using type A cable, 18 AWG shielded twisted pair. You can run it up to 1900 meters without a repeater. That's almost 1.25 miles. Pretty amazing for that data rate. But, and here's an important item, in hazardous areas zone 0 or zone 20, intrinsically safe stuff. Your distance drops. You're looking at about 1,000 meters max. The cable's distance has got to be more careful. Safety regulations. I get it. You can hang up to 32 devices on a single H1 segment. In practice, I usually recommend 8 to 10. Why? Because it's cleaner, it's easier to troubleshoot, and you're not maxing out your cycle time. We'll talk about that in a second. HSE, that's the backbone. The high-speed version, we're talking 100 megabits per second. That's using standard commercial off-the-shelf Ethernet equipment, TCP/IP, real network stuff. You can use transparent redundancy, ring topologies, modern network features. This is where you bring multiple H1 segments together if you've got a bigger site. Think of it like this. H1 is your local neighborhood. HSE is the interstate connecting neighborhoods. So you're thinking, okay, Alana, how do these two things actually talk to each other? That's where a linking device comes in. A linking device is a gateway. It's connected to the H1 segment as a regular device. It's also connected to the HSE network. It bridges the gap. But it's not passive. It's also serving as something called the Link Active Scheduler, the LAS. Think of it as a traffic cop for the H1 bus. In Foundation Fieldbus, communication is deterministic. It's scheduled. Every device gets a turn to talk. The LAS makes sure there's no collision and no stepping on each other. Device 1 sends for 20 milliseconds, then device 2, then device 3. It all happens in a specific order every cycle, like clockwork. That's huge for control applications where timing matters. And in industrial control systems, timing always matters. Here's where Foundation Fieldbus gets intriguing. Not just data on a wire interesting, genuinely smart. Devices don't just send raw measurements. They're built around what we call the block model. There are 3 kinds of blocks. Resource block. That's your device identity. Who are you? What are your capabilities? Kind of like a device passport. Transducer block. This is calibration and measurement data. Your transmitter's not just spitting out a raw signal. It's telling you the scaling, the range, and the linearization it's doing. It's sharing the processed measurement. That's already valuable. But here's the one that changes the game. Function blocks. Alright, so imagine you've got a pressure transmitter on your discharge line, and you've got a solenoid valve on your backup line. In the old analog world, you're pulling that pressure signal back to a PLC or a controller. The controller's running a PID loop. The controller decides whether to open or close the valve. The command goes back out. Now with Foundation Fieldbus, you can do something called control in the field, CIF. The transmitter has a function block, an AI block, reads analog input. The solenoid valve has an AO block, analog output. They're directly connected via publisher-subscriber. The PID loop runs on the transmitter or on a field-mounted device. No central controller needed for that loop. The devices are thinking for themselves. That changes your reliability story. Central controller goes down, your backup protection's still running, your critical loops keep working, you don't lose everything. Now the communication on Foundation Fieldbus happens in what's called a macro cycle. Every cycle you've got two parts, cyclic and acyclic. Cyclic is the scheduled deterministic stuff. That PID loop we just talked about, cyclic. Your pump status updates, cyclic. It happens on a predictable schedule. You know it's going to happen every 50 milliseconds or every 100 milliseconds, whatever you configured. Acyclic is everything else. Diagnostics, configuration changes, parameter uploads, tuning adjustments, non-critical data. Here's the practical tip I've learned the hard way. Don't fill your cycle up completely. Keep 50 to 70% of your cycle time free for acyclic communication. Why? Because real fieldwork isn't predictable. You're going to need to change a set point. A diagnostic alarm is going to fire. And you need more information. You're going to need to recalibrate something. If your cycle is maxed out, you're blocked. You can't send that acyclic traffic. You're stuck waiting for the next cycle. Suddenly your troubleshooting takes 3 times as long. Leave yourself room to breathe. 50 to 70%. That's not a rule. That's experience talking. You know what I see most often when a Foundation Fieldbus network is flaking out? Bad termination. Not software issues. Not configuration issues. Physical layer problems. Here's the rule of 2. You need exactly 2 terminators, 1 at each end of your bus. Your trunk line has a starting point and an ending point. Each one gets a 100 ohm resistor in series with a 1 microfarad capacitor. That's the terminator. It terminates the transmission line properly, so you don't get reflections, noise, or signal degradation. Missing 1 terminator, signal's garbage. You get reflections bouncing back, data errors, device drops off the network. You're swapping cables, replacing transmitters, and checking configuration, all when the problem was a 10-cent resistor and a capacitor at the panel. I've seen techs spend weeks troubleshooting a Fieldbus network when the issue was literally 2 unshielded wires hanging at the end of the cable. No terminator. They finally brought me in. 5 minutes. I'm like, where's your terminator? Silence. That's the kind of thing that'll make you pull your hair out. Don't be that tech. Learn it once. Terminators? 2 of them. Exactly. A few more things before we wrap up. Devices per segment. I said 8 to 10 is what I recommend. You could theoretically do 32. But you're going to hate yourself. Cable management gets messy. Troubleshooting's a nightmare. 8 to 10. Clean. Simple. Segment lengths in hazardous areas. This one bites people. You're in zone 0 or 20. Intrinsically safe. Your max is roughly 1,000 meters. If you try to push it further without a repeater, you're asking for problems. Plan accordingly. Cable. Type A, 18 AWG, shielded twisted pair. That's the standard. Don't get creative. I've seen people try to use some other cable because it was cheaper. It wasn't cheaper after 3 weeks of false alarms and re-terminating. Commissioning and addressing. Here's the lovely part. Foundation Fieldbus devices auto-address. You plug them in, they figure out what address to take. No manual dip switch configuration like the old days. That's actually elegant. Interoperability. Because it's IEC 611582, you've got multi-vendor gear that works together. Not always perfectly, welcome to real-world standards, but the framework's there. You can mix transmitters from different manufacturers on the same bus. There's an interoperability standard called EDDL, Electronic Device Description Language. It tells software how to talk to devices from different vendors. It's not magic, but it works pretty well. Look, here's why I'm telling you all this. You're living through a shift. It's not quick, it's not flashy, but it's real. We're moving from isolated hardware. Your transmitter does one thing, your controller does control, your valve does valve things, to an integrated ecosystem. Devices that know about themselves. Devices that can run logic. Devices that can talk to each other without a central brain. In industrial control systems, that matters hugely. Your backup systems can be smarter. Your diagnostics can be richer. Not just, is it working? But how is it working? What's the trend? When should I maintain this? Cable count drops. Panel complexity drops. But your control sophistication, that goes up. It's not going to replace PLCs tomorrow. But it's reshaping what a PLC actually has to do. Instead of babysitting every instrument, the PLC becomes a coordinator, a decision maker at a higher level. That's actually a better use of engineering time. All right, that's Foundation Fieldbus. Not the 1,000-page spec, the real story. What it is, how it works, and why you should care. If you've got questions, drop them in the comments. I read those. Seriously. If you're working with Foundation Fieldbus and you've hit something weird, I want to hear about it. There's always some edge case out there I haven't seen yet. And hey, if this saved you time in the field, hit subscribe and like. That helps the channel. Also, a super thanks helps me keep making these videos. I've got a newsletter called Scada and Beyond where I go deeper on stuff like this. The video gives you the technical foundation, and the newsletter covers the operational reality, like managing device files, scheduling segments, and all the stuff that actually keeps these systems running in brownfield plants. There's a free version and a paid insider tier. If you're interested, you can find links in the description. Thanks for watching. Catch you next time.